Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session.
Okay, so the first question is saying reflect the coordinates over the y-axis and then translate 15 units up. So there's two ways to do this. We can do the transformations to the point itself, or we can visually do it. So if we were to do it to the points, so let's take A, which is -11 and -1. If we were to reflect it on the y-axis, that means we're changing the sign of the x-axis, sorry, the x values, and then we're translating it 15 units up. So we're adding 15 to my y value, so I'm making this negative, and then I'm saying -1 plus 15. So my transform point is going to be 11 and 14. So if I were to do this visually, this is my A value, so I'm reflecting it on my y-axis, so this is my y-axis. That means I'm flipping it over the y-axis, so it's going to travel equal distances across. So I'm going to go to -11 to +11. So then I'm going to shift it 15 units up, so it's going to go from -1 all the way to +14. So that's how I'm going to transform each of these points. So that's how I transformed A. So B is going to be done in a similar fashion. So B is going to be 2 and -10 plus 15 is going to be +5. And then C is going to be 2 and 14. So my points are going to be, this is going to be my A. My B transformed is going to be transformed here, and then 15 up. So it's going to be here. And then my C is going to be 2 and 14 transformed to 2. To -2 and 1 to 2 and 14. So it's going to be reflected and then brought up all the way up here. So the next question is telling me to factor 3x squared plus 14x plus 8. So what we're going to do is I'm going to show you the general steps to take for this question, but for factoring in general. So if we have a coefficient, a leading coefficient, which is not 1, I'm going to take that and my constant, I'm going to multiply them, 3 times 24, and then I'm going to find 3 times 8 to give me 24, and then I'm going to find factors of that number. So my general equation for quadratic is ax squared plus bx plus c. So I'm going to take my product of a and c, and then I'm going to find factors for this. So in this case, I have 24. So I'm going to go ahead and find factors of 24. But I need to find factors which add up to 14. So let's go ahead and find factors of 24. So it could be 1 and 24. It could be 2 and 12. It could be 3 and 8, 6 and 4, and that's about it. So then I need to find which pair of these numbers add up to 14. So this adds up to 25, this adds up to 14, and then I'm done. So I found my factors. So I'm going to go ahead and do decomposition on this. So 3x squared plus 2x plus 12x plus, and the ending is 8 equals 0. I'm going to go ahead and factor out common terms from the first two terms and the last two terms. This is called grouping. So then I'm going to take out an x to give me 3x plus 2 plus, and then I'm going to take out a 4 to give me x plus 3x plus 2 as well. So then if I factor out the common term, which is 3x plus 2 from each one, I'll get 3x plus 2, and that'll leave me with x plus 4. So my factors are going to be 3x plus 2 and x plus 4. So to recap, this is how you would usually do factoring. I would look at what my leading coefficient is, and then I multiply with my constant to give me a number, and then I'm looking at multiples of that number. So I got 24, so I'm going to look at multiples of 24. So I found that there are 1 and 24, 2 and 12, 3 and 8, 4 and 6. But I need to find a pair of numbers that add up to my b value, which in this case is 14. So that's how I came up with 2 and 12. And then I did grouping, and then I factored out my common term, which was 3x plus 2. So these are my factors, 3x plus 2 and x plus 4. So if you're just joining in, our live session is a little different today. We're going through any questions you send in right now, and any questions we've encountered commonly throughout the week. So right now we did a question about factoring. So this is common in grade 10, 11, even 12. So the next question that was sent in it's saying how many whole numbers are between 1 and 1000 that do not contain the digit 9. So to do this, we need to find some patterns. So let's go ahead and see what it looks like between 1 and 100. How many 9s we see? So I know 9 contains 9, and then 19, 29, 39, so forth. So that means I would see 9 numbers between 100 and 1 that would contain 9. Oh, between 100 and 89, yes. Because once we hit 89, every number afterwards is going to contain 9, 90, 91, 92, so forth. So that means 10 numbers, again, are going to contain 9. So in total, we have 19 numbers between 1 and 100 that contain 9. So then if we look at what we would see between 101 to 199, we should see the same amount of numbers. So we should get 19 numbers again. So when we go from 100 to 200, we should get 19. And then after 200, all the way to 800, every increment of 100, we should see 19. So 200 to 300, we should see 19, 300 to 400, we should see 19, and so forth. So that means we would see 19 9 times between 0 to 900. So 19 times 9 would give me 1071. So then I know 900 onwards, I have 9 in every single number. So 900 all the way to 999, I have 9 in it. So 100 numbers between 900 and 999 contain 9 in it. So if I were to add, this is 171. So if I were to add 171 with 100, give me 271. So out of 1000 numbers between 1 to 1000, I have 271 numbers that contain 9. So the question's asking me how many numbers do not contain 9, so I just do 1000 minus 271 to give me 729. So this question was asking me to think about patterns. It's saying how many whole numbers are there between 1 and 1000 that do not contain the digit 9. So I went through between 1 and 100. Between 1 and 89, I have 9 numbers which contain 9, and between 90 and 100, I have 10 numbers. So in total, between 1 and 100, I have 19 numbers that contain 9. So I repeated that for every increment of 100, and I realized that 19 times 9 is 171 because it increments by 109 times before 900, and every number after 900 before 999 contains 9. So I know there's 100 numbers that contain 9. So I just added 171 and 100 to give me 271. It's a thinking quadratic application question, so it's saying find two consecutive numbers that multiply to 462. So I need to come up with an equation first before I need to solve it. So I'm going to say two consecutive numbers, so I'm going to say x and then x plus 1 that multiply to give me 462. So I'm going to evaluate these brackets to give me x squared plus x equals 462. So I'm going to isolate for 0, minus 462 is equal to 0. And then I can evaluate what my x is either using factoring or the quadratic formula. I don't want to factor this big number, so I'm just going to use the quadratic formula. So minus b squared plus minus b squared minus 4ac over 2a. So I'm going to plug my b, a, and c values into this equation, and I should get x is equal to my 21. That means if x is 21, I should be able to get x plus 1, which is just 22. So the two numbers could be 21 and 22. So 21 is the number I got from the quadratic equation. So this question was asking me to find two consecutive numbers that multiply to give me 462. So I said x could be any number. So since they're consecutive numbers, I just said the next number is x plus 1. So when I multiplied the two, I should get 462. And then I evaluated this expression. I realized it's a quadratic, so I plugged my numbers into my quadratic equation to give me my x value. So let's move ahead to the next question. So once again, this is a special live session. We are asking you to send us any questions and we'll be solving them in the live itself. You can send them through the DMs or you can send them through the live session itself, live session messages. So let's get started with the next question. So we're in grade 11 still. So we're asked to find the value of k if f of x is kx squared minus 3, and then the inverse of that at 121, 122 is 20. So they gave me a value of x and y at my inverse. So that means I need to find what my inverse is first. So let's go ahead and do that. So I know my y is equal to kx squared minus 3. So to find the inverse, what I do is switch my x and y value. So I have x is equal to ky squared minus 3. And then I'm going to isolate for my y. So I have ky squared is equal to x minus 3. And then I'm dividing by k. And then I'm going to square root both sides. So x minus 3 over k. So then I'm told that my y negative 1 is going to be 20 if my x is 122. So I'm going to plug 122 into this and 20 into this equation. So my y is going to be 20, my x is going to be 122 minus 3 over k. This should be plus 3 because I brought it over. So then I'm left with, if I'm trying to isolate for my k value, I should square both sides. So to give me 20 squared is equal to 122 plus 3, which will simplify to 125 over k. So then my k is going to equal to 125 over 400. And that's going to give me 5 over 16. I can get a decimal, but I'll leave it as a fraction because it's nice. So we'll get started with the next question that was sent in. So it's dealing with the factor theorem. So we're given an equation when x 2x cubed plus x squared minus 2kx plus f is divided by x minus 1. The remainder is negative 4. When it is divided by x plus 2, the remainder is 11. Determine the values of k and f. So this is using the factor theorem. So what the factor theorem or the remainder theorem is telling me is if I'm given this, so let's say f of x is this function. That means if I divide by x minus 1, the remainder is going to be negative 4. But if I plug in the factor, which in this case is 1, okay, I should be getting negative 4 as well. That's what my remainder theorem is telling me. So using that, I'm going to come up with two equations. So first is going to be when f at 1 is going to equal to negative 4, and the next is f at negative 2 is going to equal to 11. So these are the two conditions. So let's go ahead and simply plug in x is equal to 1 into the function. So I'm going to plug in 1 cubed plus 1 squared minus 2k at 1 plus f. All that's going to equal to negative 4. Right. So I'm going to simplify this as much as I can to give me 2 plus 1 minus 2k plus f is equal to negative 4. So then I can make this 3. I'll bring the 3 to the other side. So negative 2k plus f is equal to negative 7. So that's one equation, right? Because I used f at 1 is equal to negative 4. Using the remainder theorem, but I also have another one which is f at negative 2 is equal to 11. So f at negative 2, I'm going to plug in negative 2 into each of my x values. So negative 2 cubed plus negative 2 squared minus 2k minus 2 plus f is equal to negative 4. In this case it's going to be 11 because my remainder is going to be 11 when x is at negative 2. So I'm going to evaluate this. So 2 times negative 8 plus 4 plus 4k plus f is equal to 11. Then I'm going to try and get it in the same term, my equation in the same form as my previous one. So let's call this 1. So 2 times negative 8 is negative 14 plus 4 plus 4k plus f is equal to 11. And then I'm going to isolate for my numbers. So I should get negative 12. Bring the negative 12 to the other side to give me plus 12. So my 4k plus f is equal to 23. So then I have two equations with two unknown variables. So what I can do is I can simply plug in. So then I can make f is equal to negative 7 plus 2k, and then plug that into my second equation. Right. So 4k plus negative 7 plus 2k is equal to 23. So then I get 6k, bring the negative sign to the other side to give me 30, and my k is equal to 5. So once I find the k, I can plug it into this equation. So I know my k is equal to 5. So my f is equal to -7 plus 2k, so k is 5, which will give me -7 plus 10. In other words, f is going to be 3. So to recap what we've done, we use the remainder theorem, which tells me if I divide a function by a binomial, so in this case it's x minus 1, that means my factor, which if it's x minus 1 is going to be plus 1, if it's x plus 2 it's going to be minus 2. If I plug that factor into my function, I should get that remainder. So I've been told the remainder was -4, so that means f at 1 is going to be -4 and f at -2 is going to be 11. Then I evaluated the function at each of those points to give me an equation in terms of f and k. And then I had two equations with two unknown variables. So I did use substitution to plug in f is equal to -7 plus 2k to find what my k is. Then I plugged it back in to find what my f is. So the next question that was sent in is telling me to find x and y. So once again, these questions could be all types of levels, so it could be from all the way from middle school to high school. So it's asking me to find x and y. So I know these sides are the same because of this symbol, so I know this is 5, so that means my side is going to be 5. If this is 8, that means this has to be 5 as well, so my x is easy to find. It's simply going to be 8 minus 5, so my x is going to be 3. And for the y, I have to use the Pythagoras theorem. Right? So I know y is, I'm going to write my Pythagoras theorem, it's a squared plus b squared equals c squared. In this case, my y is going to be my c. So I have c squared is equal to x, which is 3 squared, plus my other side is going to be 5 squared, so this and this. So to find what y is, I have to get the square root of 3 squared, which is 9, 5 squared, which is 25. So the square root of 34. So my y is simply going to be square root of 34. If I want a decimal, I can plug that into the calculator. Right. I did that because this symbol tells me that both the sides are the same length. So I know this is 5, so it gives me a square, so this is 5 as well. I know all 4 sides are 5, so that means x is going to be the total distance, which is 8 minus my 5, which is what I got, which was 3. And then I use the Pythagoras theorem to solve and find what my y value is. So the next question sent in is telling us to factor this. So first I'm going to rearrange this equation to give me y squared minus 7xy plus 12x squared. Right. So then I'm going to look at what is these two terms that add up to -7, essentially. So I'm looking at 12, and I'm looking for factors of 12 that will add up to -7. So that could be 6, 2, 3, 4, 12, 1. Right? But they need to add up to -7 because the signs are important. This sign tells me that the two numbers that I'm choosing have to multiply to give me a positive number, but this sign tells me that the two numbers, if I add them up, give me a negative number. So the only possibility is if both the numbers are negative. That's how I can get a positive number here. So that's why I'm going to use 3 and 4, because if I add them up, I'm going to get 7. So then I'm going to use decomposition to give me y squared minus 3xy, and then minus 4xy plus 12x squared. So then I'm going to factor by grouping to give me y minus 3x minus, I can factor out negative 4x to give me y minus 3x. So then if I factor the common term, I get y minus 3x, and I'm left with y minus 4x equals 0. Or I just can leave it as it is. So my factors are y minus 3x and y minus 4x. So we'll start with the next question that was sent in. So this question deals with a quadratic geometric applications. So we're given that someone's designing a pool that consists of a rectangle and a semicircle. He must ensure that the perimeter of this pool is exactly 2,000 meters, and they would like to maximize the area of the rectangular portion of the pool. What dimensions will allow him to do this? So the first thing we're going to do is write an equation for my perimeter, because that's the amount that's given. So it's going to be length, width, and another length, and half a circle. So I have length plus 2 length plus 1 width, plus my perimeter for a circle is going to be 2 pi r. I need half of that, so I just divide it by 2 to give me pi r. So I know my perimeter is equal to 2,000. And I want to get this in terms of two variables, my length and width, because I don't want length, width, and radius. So I know my radius is going to be half of my width. So then I can say 2L plus W plus pi width over 2 is equal to 2,000. So the next thing I'm going to do is isolate for my length. Why? Because I have an equation for area, which is length times width, because I'm only maximizing the rectangular portion. So I'm trying to find the maximum area for using length times width, but I don't want two variables, so I want to get my length in terms of my width. So my length is going to be equal to 2,000 minus width minus 2 length. If I want L by itself, so I'm just going to divide everything by 2 to give me 1,000 minus width over 2 plus length. So then I can plug that into my area equation. Right, so I have 1,000 minus width over 2 plus length times length. Sorry, times width. Sorry, this should be pi. So what I'm doing in this case is just isolating for my length. So this question is dealing with quadratic geometric applications. So I was given a perimeter, so I came up with an equation for my perimeter in terms of my length and width, and I converted my radius into a width as well, and then I was isolating for my length. Right. And then I'm going to plug everything into this equation. So my equation of area. So just to simplify this, let's go back and see if we can simplify this any further. So my length could also equal 1,000. If I factor out my W, I simply have 2 plus pi over 4 times w, and that's what I'm going to sub into my area equation. And all of that is times another w, because my area is length times width, and my length equation is this. So I have a quadratic equation. So what I'm going to do is try and find the vertex of this quadratic equation. So this seems to be given to me in factored form already. So w is equal to either 0, which is one factor, or this entire thing is equal to 0. So I need to find what that is equal to. So I get 1000 minus 2 plus pi over 4 times my width is equal to 0. So if I isolate, I should get width is equal to 4000 over 2 plus pi. If I put that in a calculator, that should give me 778. So my width can be equal to 0 or equal to 778. So those are my x-intercepts, but I'm trying to find the vertex. So what I'm going to do is just add the two together to get my vertex. So 778 plus 0 divided by 2. That's going to give me 389. So the maximum area I can get is when my width is 389. So to find the other dimension, which is my length, all I'm going to do is substitute my width into that equation. So my equation was this thing over here, so I'm going to rewrite that just to make it clear. So it's going to be 1000 minus 2 plus pi over 4 times my width. And then I'm going to substitute my width, which was 389, and then plug it into the calculator, which would give me 500. So the dimensions that are going to maximize the area is going to be my width, which was 389 meters, and my length, which is 500 meters. Just to recap what we did, we wrote an equation for my perimeter. I wanted it in terms of my length and width only, so I converted my radius into my width, because I know my width is twice the radius. And then I went ahead and plugged it into my area equation, which I know is length times width. So I got length in terms of width and I plugged that in. I solved for my two x-intercepts. I found the vertex, which is the midpoint between the two x-intercepts. And then I found my width. And then I just had to plug my width back into my length equation to find what my length was. So the dimensions that will maximize the area is this. So once again, we've gone through some questions that you guys have sent in, and some questions that we commonly see throughout the week. If you have any questions, we'll be happy to help you out. But that about does it for me today. So thank you for tuning in. And once again, if you have any math questions, we're a service dedicated to helping students out. So we'll be happy to help you guys out. And we hope you have a good night. So take care.